Uh, Hi, and welcome everyone. We are here to give you a little bit of overview on teaching with the UC Berkeley Datahub and teaching with Jupyter Notebooks in general. And
Hello, Roger.
First I want to introduce myself.
To watch this using Jupyter Notebook by.
I am a staff member who does outreach on behalf of UC Berkeley to other places wanting to teach data science, and I do a technology outreach for people who are interested in teaching using the Datahub. I work for data science undergraduate studies. I'm also a lecturer, so I also teach using this, and I've been doing this for a few years, and I'm also really interested in helping faculty to develop new curriculum in this area. I would like to introduce my colleague, Elias Saravia.
Hello, everyone. If you hear an alarm, I apologize. But yeah, I've been working with modules for over 2.5 years. I first started off as a developer, a student developer. I eventually became a team lead, started leading projects. I've led over like 9 projects. And now am part of the modules team as the curriculum coordinator, part of staff. And I'm really excited to be here and give this presentation to y'all.
And I also want to introduce my colleague, Balaji Alwar.
Hi, everyone. Happy to be here. I'm the service lead for Datahub. So I work for 2 different departments, DSUs like Elias and Eric, and also research, teaching, and learning. And my role involves working closely with Eric and Elias for these workshops and working with the tech team from documentation outreach standpoint.
Great, thanks. So just a starting point, like our vision here is for students across campus to be able to touch data science and meet students where they are, whichever discipline they are, wherever they are on campus, that they would have a capacity to touch data science, to learn about the major and minor, to learn a little bit of like what these tools are and how they work, and present that in a friendly, accessible way to them. So they're not, that data science isn't something like over there in the corner that only, the smartest people do, that this is something that everyone can touch. So what we talk about this in helping other classes. We talk about building modules for other classes, and I'll let Elias talk about modules.
Yeah, so like what basically is a modules curriculum? So that's essentially a laboratory assignment, a homework, a project, or a lecture that you introduce into the class that uses Jupyter Notebooks to expose students to data science tools or concepts, such as principles of data analysis, interpreting and creating data visualizations, introducing statistics, etc., all in the context of your course or domain. And in addition, with modules, students get the opportunity to work on a data set that's more relevant to their course, that achieves the necessary learning outcomes. Some notable collaborations that we've had already are with Civil Engineering 110, Engineering 157 AC, Mechanical Engineering 103, and we have more to come with collaborations.
So another thing that we've done is built out connector courses. The idea is a connector course is for students who are in the Big Data 8 course. Then they have a 2-unit connector course where they'll learn about something like an application of the tools in Data 8 out in a course that they might be related to their major or something they're interested to explore. We've had 3 of these with city planning, and we'll hear from Marta Gonzalez in a little bit about her class that's ongoing. But I will just say early on in the early days, before I was involved, I think Mark Stacy was one of the pioneering people putting together a connector course for CE a few years ago.
You want me to comment on that briefly, or?
Sure, go for it.
Yeah. So yeah, this was when the ideas of connector courses had just really emerged, and I thought it would be a fun experiment to jump in, and it was. I didn't have the bandwidth to continue it, but it was engaging with a different set of students than we normally see in CE. It was students from across campus, non-engineering students in their freshman year, who were just learning the tools in real time. And essentially you're trying to kind of give them almost like example problems along the way in the topical area that you're building your class around to make use of the things that they're learning in Data 8. It went fine, but I wish I would have had an opportunity to cycle back to it. It was long enough ago now that it would be starting over from scratch to revisit it. But I enjoyed the experience.
Awesome. Well, just kind of moving on, we do have more in place than when Mark started out. Like there's more in terms of like how to use the Jupyter Hub. We have a team that can help build notebooks for you. And we have sort of more built out in the connector space. Elias.
Yeah, in terms of the module space or in general, like the work that we've done, we've been creating curriculum for over 5 years. And over the 5 years, we've served over 13,000 students, served over 80 courses, created over 250 notebooks, and served over 40 departments at UC Berkeley, including, but not limited to, economics, ethnic studies, political science, biology, here with y'all with civil and environmental engineering. And specifically with civil and environmental engineering, we have collaborated with them since 2019 and have served over 240 students, worked with 5 courses and created approximately 26 notebooks. And from these notebooks, we had like 14 come from modules and 12 come from E7 alone, which we might talk more about. And yeah.
Okay, so one thing to think about is this is a combination of open source technologies here, right? So it's something that we would call like a teaching stack or a pedagogy stack, right? So it's not just about students learning Python. Students learn Python in a way that's really friendly to them. If we're going in the Data 8 world and the Data 8 connectors world, there's a learning package for learning Python called Data Science. That's the sort of a friendly intro to like NumPy. It's before you would learn pandas. Jupyter is this, way to deliver interactive coding in a browser window. It supports a whole bunch of rich pedagogical applications. Finally, the whole stack that runs the Datahub at UC Berkeley is an open source stack with tools constantly being built and adapted. People that contribute to the main Jupyter Hub project sit here at UC Berkeley and help us to deploy this server. The way that we deploy as instructors, we deploy our notebooks is through GitHub, which is one of the main places that people are doing open source software development. So we're using the tools of open source software, like development tools, we're using those with our pedagogy tools as we deploy them. And then one of the really cool things that's been developed at Berkeley is this thing called Interact Link. So I can set up my class on GitHub, as like a file server. And then students at Berkeley can just get a link through email, through B-Courses, through a course website. And that Interact link will open the interactive notebooks in a browser tab. So this is really making it easy for new students who are learning to just get right into the computing in the lesson without like worrying about the environment and packages and compatibility. That environment's set up for them and then just go right into the curriculum of the lesson. Another part of this open stack that I want to say is like, we have these amazing students that learn this while they're undergrads and lean in as volunteers to be part of the team with Elias and help build the materials. So the students are learning a bunch of great practices and having really excellent, it's not a research opportunity, it's like a building curriculum opportunity for the students, but they learn a lot by participating in this modules program. I'm hoping that most people on the call know what a Jupyter Notebook is. It's a place where you can have code, you can have instruction, you can have the outputs all in the same place. And there's incredible examples at UC Berkeley if you want to browse some that are very pedagogical, like there's like whole textbooks and lecture notes written in them. The textbook and what your homework is, we're breaking down the wall between those things. We also include this slide because last time we gave the talk, we were with the sociology department where half of the people didn't actually know what a Jupyter Notebook was. So we wanted to make sure that we explained that early on. You can format equations in LaTeX. A lot of what we're doing is like, here's the equation, here's how you'd program the equation, here's the package, here's the visualization of how that output will be. When we get to the examples with the professors, I think you'll see more examples of what the cool outputs can look like. Biology for the Datahub.
Yeah. So what is Datahub? So Datahub is Berkeley's instance of Jupyter Hub. And as Eric said, it's open to anyone with UC Berkeley email ID. It was initially built for Data 8. I will walk through the history in the subsequent slides. The vision was inclusion and accessibility. Any student who either from STEM background or non-STEM background can actually use Datahub, right? So the inclusion and accessibility is at the core of the development of this tool. And irrespective of the compute they have in their local machine, they can access the cloud and they can use it without worrying about licenses that proprietary software requires. And it is easy to deploy in lectures or in labs or homeworks, as we have seen with multiple courses doing the same. And it was initially built to be scalable. So when it started, it was less than 100 students as part of Data 8, but as I'm talking today, we had almost 1,700 plus students as part of Data 8 use this particular stack. So that talks about the scalability. And finally, it is built for reproducible science. Students can, for example, students can take up a research paper, run their own data set to corroborate the experimental outputs. So those are the key features of Datahub. Eric?
Yeah, and I just want to say, like, it has significant value for the students, right? So this is a tool that can be used, that's been built for this Data 8 class with 1,500. I think it has 1,700 students. Today was the first day. But it also can work in a 30-person class, right? So this is a set of tools for active learning, for giving students the hands-on compute. But this is also, in the data science world, this is like an industry standard platform. So this platform that's really useful for delivering content to students is also something that people who go into these fields could be using in the work world. And then I also want to say, like, these things are stacking together. So if you look at the Data 8 stack, like, there's an open source textbook, there's a software stack under it, and then the curriculum itself is open source. So, and I don't know how this is different for every different faculty member, but the Data 8 project has been really able to scale broadly because the way they built the curriculum and hosted it in public places. And so people at other universities can share examples and borrow what they want to borrow. And so finally, it's just also really robust that these tools are not tools for like a single department or a single part of campus. Digital humanities, social science, engineering, all can be using similar tools.
I would like to just walk through this slide to show the contribution Berkeley has made to the open source community in general, like folks within the Datahub team. So initially in 2015 or 16, that's when the Project Jupyter folks released Jupyter Hub as an initial prototype. And it was widely adopted as part of Data 8 in a course in 2017. Prior to that, all the assignments would be uploaded in vCourses or relevant other tools, and students have to download it, set up their local environment and start working on it. And from 2017, it changed. And initially, once Data 8 adopted it, many other instructors expressed interest using this tool. And many of them were using R tools like RStudio as part of their instruction. So the team here within Berkeley, they added RStudio as part of the Datahub offering in 2018. And this was not offered as part of the Jupyter Hub open source tool. So this is one of the contributions Berkeley made to the open source ecosystem. And in 2019, there was a MOOC called Introduction to Data Science, Foundations of Data Science, which had Datahub integrated. So that way students who are not part of Berkeley, who enrolled for this course, could also use Datahub, run their data science work there. And with the growing user base in 2020, the folks within Project Jupyter ecosystem and Berk ecosystem, a bunch of them joined together and formed an organization called 2I2C. And the vision for this organization is to make open tools for interactive computing. And they currently work with universities and community colleges to deploy Jupyter hubs to basically help those colleges who can't set up, who don't have the technical capability or the resources to set up these environments. And also after the pandemic, like a lot of instructors started adopting Datahub. And as I'm talking, we have almost 10,000 users using this tool on a regular basis. So quickly wanted to walk you through some stats. So we have around 4,000 plus users on a weekly basis. And we have almost 10,400 plus users who use it on a monthly basis during the peak time. We had almost 60 plus courses across the campus using Datahub during fall 2021. And just to give a mental model of the kind of usage we have, so we have almost 150 years worth of student time spent in Datahub from the year 2019.
So here's a set of classes that we've worked with engineering, and hopefully we can just walk through these and give examples of how materials have been created, how classes have been taught. And I think we have a bunch of the instructors here that can talk to some of these. I will circulate this slide deck, and if you want to come back, these links and the links on the other slide will bring you to where the materials are specifically. Or I don't know if Balaji or Elias, you could throw the link to the slide deck in the chat. So if people want to click through to some of the materials while we're here. One thing I want to touch on, and I don't want to get into this if it's too political, but you know, how this affects the students in the civil and environmental engineering major. First of all, data 8's a requirement for the major as far as I understand. So, you know, one thing to think about is like students will have completed something like over 20 Jupyter notebooks in between the labs and projects and homeworks, and they'll be coming into your classes with those skills. So they will have like already been in this world, working in this, ready to go. Engineering 7 is a different story. So Engineering 7 is still taught in MATLAB. The Engineering 7, the textbook and all the labs are all translated and ready to go in Jupyter notebooks, which brings just to a general question of like Python versus MATLAB. You know, obviously, like we're super passionate about the open source aspects of Python and the way that that really makes it easy for us to distribute things. But I understand that there's lots of professors who want students coming up knowing MATLAB as well. But I also know that I think there's a process underway to hire a lecturer for civil and environmental that would be potentially teaching data science at the lower division level as well. All right, so let's move on to content. And we have Jen Stokes-Drought here, who worked with us for creating some Jupyter notebooks for CE 110. Jen, do you want to take over for a couple slides?
Yeah, I can. So we use a data science module in Water Systems of the Future. Car and I teach the class together. We've done this. This will be our third time, I believe, when we do it this semester. So we have a little bit of experience with it, and we use a couple of lecture periods and maybe a discussion to give the students time to go through the notebook that we've developed. I'm wondering if we'll have to spend less time on it now that I think this will be the first time we offer it where we have a larger percentage of the students who are more familiar with Python. So it may be that we adjust that this semester. But basically what the notebook is designed to do is to allow the students to look at how different water utilities in California are interconnected and what that means for their energy consumption. So as part of the class, the students are assigned to one of 8 groups where they really look into detail at the water supply for different water utilities. And so we have this this network map of how water moves around the entire state that you're seeing here in pink, yellow, and green. And highlighted in red are the utilities that they care about, that their group projects are focused on. And so basically what we're trying to do is pull out the data that's relevant for their particular water utility and do some calculations with it so that they can see the power of this method. Next slide. So the first thing we do is we give them code to actually identify their utility and pull out every connection that's upstream of that. So they end up with a picture that looks like the one on the right. The nodes that are colored green are kind of like considered to be lower energy sources, whereas the red ones are high energy sources. So we start seeing how energy is used in their water supply, which is a concept that we've talked about throughout the class. And then next slide. Once they have that sort of node diagram, we allow them to download a file that they go to a different website that allows them to see the data differently as in the form of a Sankey diagram. So here actually the width of the lines correspond to the flow of water between the different nodes. So before you were just seeing, nodes and lines, and now you're seeing actual information encoded in that. And if you hover over any of these boxes, it gives you a lot of information about, what infrastructure is there, how much water is flowing through, and then what the energy intensity is that's associated with that particular box. So they can just see the data differently. And then next slide. And then finally, we go in and start doing calculations on what the actual energy intensity is for their particular water system. And this is connected to, they've already done a homework assignment that's shown here on the slide, where they calculate by hand how those calculations are done in a very simple way. But the notebook allows them to do it for all of the water sources associated with their particular utility. And we choose utilities that have very complex water supply portfolios because they're the most interesting. And then it also allows them to calculate what's the energy intensity of water supplied in the entire state. So having gone through the calculation by hand, they know how difficult it is to do a very simple calculation. And so it allows them to see the power of doing this kind of data science and using these kind of platforms to process the data. Next slide. And then they just end up with a bar chart that summarizes all of the different water sources that they have for their utility and their relative energy intensity. So it really does allow them to dig in to the context of their particular utility that they've been looking at the entire semester, and ties together problems that they've done as part of their homework throughout the semester. So we do this near the end of the semester, just to sort of tie everything together. Happy to answer more questions if there are some. Or did you have things you wanted me to address, Eric?
No, that was super helpful. Thank you.
Cool.
Anybody have questions for Jen, or should we keep going? I cannot see everybody, but here we go. Okay, really quickly, Khalid Qadir was unable to be here, but we had built a nice module with Khalid a couple of years ago for his engineering 157 class. And they had, it's another way to think as an instructor, they had a pre-existing homework that was going to the Cal EnviroScreen website and downloading some data from there. And that was like exposure to toxics, exposure to lead. He also had an international one that was like comparing between countries with emissions levels and GDP or indicators of development. So it was Khalid brought us homeworks that he already had, that it was, and we were sort of like able to make materials that matched his pre-existing assignments, but sort of upgraded the level that the students could do the analysis or run a basic correlation or do some simple mapping. So, and Khalid gave me this nice quote that was like, it helps to be focused on the learning goals of the assignment to build the notebooks around the learning goals. It can be easy to get distracted from those in the process of taking on a new technology. So, it was a good collaboration because Khalid was, not necessarily a data scientist himself, but like working with our student team to make the notebooks that would fit with the curriculum in his class. Another project that's recent, this is in mechanical engineering with Professor Maki Harju. We just finished these, but because they have to do with fluid dynamics, I thought that a bunch of you would be interested in this. And I had talked to Evan about this a little bit. So this is, fast Fourier transforms, 2D flow. And this is an interesting combination of like, there's some modeling, like what if we just took the equations for these flow diagrams and modeled them and created a model. But then also there's like a lab time. So there's a lab where there's a probe in a wind tunnel. And he also wanted to make one for a wave tank. So then could your model with the Fourier transforms be matched to what the probe that's in the actual lab desk demo? Could you match those two up? And then another thing that was interesting was, we're in this funny time of remote instruction. If there's 100 students in the class, maybe they all can't get in to have a demo with the lab machine, and maybe just a few students could go in, get the lab machine, generate the student side data, but then all of the students could analyze that data in the notebooks. So there, some combination of like synthetic data, lab bench data, and like instructional data. So I thought that was a nice collaboration. Those materials got built last semester and hopefully are going to get deployed this semester. And the other part of this project that will be fun, hopefully, is there will be a wave tank in Echeverry Hall that you can go by. And so the one funny idea there was you could go by and interact with the wave tank in the window of his lab, but then you could download your data set for your homework from your interacting with the wave tank in the window. Another project that was really interesting, Professor De Jong is here. And this was putting some really, really high frequency sensors up in the campanile and sort of gathering big data. Matt, do you want to talk about this?
Yeah, sure. I had a couple of students help me out with this, and a couple of the people provided by Eric's team who were incredible. They're very good to work with. They are very good at what they do and thorough, so it was fun. We basically took some trial data, recording accelerations at the top of Sather Tower, and the objective was to create a notebook which could teach some concepts with this example data set. So teach them fast Fourier transforms like spectrograms, other ways of processing dynamic data, and gives them kind of the interactive code to learn how to do it, and then try and get them to record some data on their own. I mean, this is the future. We haven't implemented this in the class yet, but for my dynamics class is to have them go record data with their phones or other things and use the same Jupyter Notebook, just modify the scripts and try and process that data, understand it better. My idea with getting involved was basically because we teach them tons of theory on this, but none of them have seen, by the time they finish our classes in dynamics, or any real data from a real building or otherwise moving. So I was trying to incorporate like a real practical hands-on aspect to the class. So I don't know if there's another slide or not, but that's basically an overview of the project and why I got involved.
Cool, thank you. Yeah, I always say, like, wouldn't this be awesome if this was something in E7, like where you basically in E7, you would like learn some basic programming, but then like, oh, look, there's a super cool application, and I guess it's a nice, I always still thought it was nice where like, it generates a lot of data. Those sensors like generate a giant stream of data, and like we can only compute and look at some subset of that. So that's like a little just, lesson for the classroom as well.
And ongoing, hopefully we're going to have the system. We just took some trial data, but there will be a continuous monitoring system there. So students could access the data, look at it real time, download some real time and play with it that way. So that's the long-term plan, but we're still working on it.
That would be so cool. I hope that works out. Okay. So I'm going to move on to City Planning 88, which is also Civil Engineering 88, a cross-listed connector. Professor Gonzalez, who will be teaching her third semester of this class this semester on network analysis. Marta, you want to step in?
Yes, I'm going to turn off my camera because my internet is unstable. This class teaches network science for cities, and there are 14 classes, and we have 4 homeworks. The homeworks are all based in a Jupyter Notebook. The type of techniques we learn in class are NetworkX, that is the package to analyze network clustering algorithms, methods of analysis of a network, and spatial analysis. I am having here 2 screenshots. The first is the first lecture where we build a network, and the lower part is dynamics on network. This is a water model in which the nodes start changing their state. I want to add that first, I had all my classes in MATLAB, and the reason I like MATLAB is because it have online help and very powerful functions. It turned out that Jupyter Notebook have the same with an additional advantage that is very easy to teach. Notice that you have comments in the sections and the codes are broken in small pieces. Then you can have that very pedagogical way to go through programming in a very friendly environment. That is the power of Jupyter Notebook. I want to add that the power of the Jupyter Hub is that the students can connect to the university to remotely work in Jupyter Notebooks. What is the advantage of that? That you have all the packages and the students do not need to have the latest environment in Python nor the most powerful computer. Then it makes the things really more accessible. Then next slide, please. The highlight of the class are the capstone-like projects. For example, in the left-hand side, we are able to do a clustering method. Every point and color is a census tract, and you see the different distribution of income. So we have the purple one with 150K or more, the median household income, or the bluish one that is less than 50K household income. And we would be seeing the accessibility of EV station, charging station, depending on where you are. Then the scatter plot tells you that the less dense, to the right, the less dense census tracts are having the major percentage of EV charging station, which makes no sense. You have more EV charging station where less people is. If we want electric cars to be sustainable, you need a charging station for everybody. Similar to the right-hand side, this was one project of a student. I was very proud because he put the project in GitHub. That allowed him to have a portfolio when they go to look for work. And I think it's because the environment that the Datahub gives, that my class was in GitHub, he put his project in GitHub. Here we see in Manhattan the map. Notice that thanks to having the Python notebooks, we have the libraries that download data from census. Then the red map is the population density in all these census tracts. On top of that, we have the subway network, and we have the density of stations in yellow, for example. Then you see that in Manhattan, you have more dense stations close to each other than where more people live. Again, this allows them to talk to city planners with the language of network science. Well, that final slide. Then that allows them, it was one student that started analyzing the simple things of dynamical networks in 2020 and end up having a published paper, first author, because he moved on to analyze actual data on mobility among colleges. And using the network properties, he would define the method, how if you do certain testing strategies in the network, you will have less infections in the different colleges. So what I have learned in this class, that thanks to the support of the Datahub, we can do magic things with data and students get very motivated. My weakness point at the moment is that the content is very high level, and I usually have a class of 30 people that is very happy. But what I'm going to try is to lower down the level to be similar to the previous class that have at least 60, 70. That is my goal for this semester.
Thank you. Wonderful. It's really cool to hear the students going on to do research.
Yes, with the magic of data science, that's possible.
Nice. Just have a couple more slides. One is Abdulaziz, who was not able to come. We usually like to highlight a student who was part of the department and then worked with modules. So Abdulaziz is just an amazing person if you ever met him. He had actually worked with our modules team as a developer for a couple semesters. We even had a module for a French instructor, and Abdulaziz spoke French because he's from Cote d'Ivoire. And so he was able to help us with the digital humanities project. And then the Sather Tower project came, and he was in a master's and was able to help Professor De Jong with the Sather Tower project. And now he's going on to a PhD at UCSD in civil environmental engineering. And he wants to, work on machine learning and monitoring building health. So it's just really cool pathway here. And he's somebody who came to us as a student volunteer and then ended up making some big contributions. And this is definitely part of their career pathway. Now, sorry that Abdulaziz couldn't join. He's at a consulting firm this year, but he's definitely still around and engaged. So if you're interested, we have an interest form you can fill out. There's a textbook, you can go and look at examples. Balaji has a newsletter that comes out monthly. That's what are the latest things and what are new tools, how to do auto grading. Finally, one of the easiest ways, or one of the most powerful ways to explore it, is to go on the GitHub and just sort of explore the GitHub and see other people's classes. So the modules GitHub just has all sorts of different examples, econometrics, political science, but there's other engineering examples on there. Most of those things are also linked in this slide deck directly. We would love to meet with you and talk through your use case. You can email us, ericvd@berkeley.edu, or Elias's email is in here too. We would love to meet with you one-on-one and help out. This semester, we're planning to work with Professor Ivy and Professor Carrasquillo on two sort of classes with new curriculum that they're working on. One is a social justice class with looking at social justice examples. And then Professor Ivy's class on data analysis. And so she made a call out to other folks in the department who had good data sets to use as examples. A slightly related one is we have this bio-inspired design class that does something with the mechanics of a gecko and the mechanics of a cockroach. So we're going to be working with them this semester. But we're interested in all sorts of other types of classes. I will go to Tina's question. This is a very important question, what about people collaborating on notebooks for team projects? And I talked to Tina at the CEE picnic, who said that she preferred to use Colab because it was easier to collaborate. I'll say a couple things here. One is, lots of people in lots of classes, Data 100, Data 8, lots of people find ways to collaborate and do teamwork in all sorts of classes. We don't have that possibility of real-time collaboration on the same notebook. right now. This is being enabled in one class this semester, Stat 159, which is a reproducibility, open science class. And so we're piloting in this class. What happened is that the real-time collaboration tool, as it got released for Project Jupyter natively, basically shares all of your files. So there's no way to limit sharing just to a single file or a single folder. So that's what, when we're teaching with lots of different classes on Datahub, or if you want to have some, personal projects and some group projects, we didn't feel like that was the right way to release this new version of like Jupyter Hub sharing. So we are going to pilot it this semester with Stat 159. And if this is something you want to do, we could potentially enable your class to have to be on a hub with sharing capabilities, or make it a separate dedicated hub for your class. Or we're going to have to wait for the people developing real-time collaboration at Project Jupyter to make it so that you could just share like one class or one folder or something like that. So,
Thanks for clarifying that. Can you just explain what that would look like for a student in class then? Would they, if they created a folder for the class, then everything would be shared? Is that what you're trying to say?
So right now, the way it works is you share all the way down to root. Everything that you have is shared until you log out of the session. So what happens?
Anything they ever did in any other class or anything else they've
stored. That's our problem. That was my problem, was I didn't want to release it. So what we do right now with Datahub is it's able to scale to 80 classes and 10,000, thousands of users, is because, it's okay to have other people's classes on there. I can't see into your folders for other classes, right? So the real-time collaboration gives you like root access until you log out of the session. It's basically, I share a little link with you. It's super cool. I'm happy to demo it with you. We could both go over to the Stat 159 hub and log in and try it, and you could try it. It's like super duper promiscuous at the moment, and so I didn't feel like it was safe for, I got a little worried as an instructor. I would say tons of students the main instruction of the class might be on the campus data hub, but they might go collaborate on Deep Note. Do you know about Deep Note? If you're interested in RTC, it's definitely like a commercial company that gives away its services for free to education. Deepnote.com, they're super cool. They love us. They would love to have your class. I personally like into supporting the open source university one, but Deep Note is a fantastic one that's given out for free for education, or Google Colab. And so lots of students in lots of classes will go over to those, work on their homework, and then submit, or like have a finished version on Datahub, which I think is reasonable also, where you have like, the core set of the classes is that everyone gets their own copy. If you guys want to collaborate on a copy, how you turn that in, that's like part of a separate workflow. Data 100, there's tons of classes that do group projects, and the students, have multiple ways to figure out how to do it.
Thanks.
Importantly to point out, Tina, too, as an instructor, you can get admin access. So when you have admin access, you can go in and help any student. So importantly, the way Data 8 is taught is that, the GSIs in Data 8 will have admin access, and so they can go in and go into the specific notebook of the specific student. It's it was meant for an earlier day where like there were problems and you needed to just restart their kernel, not as much for like debugging and like, oh, you're missing a bracket on line 17. But there is that capability of like the instructor can have the ability to go into student notebooks. I just want to say really quickly, Abdulaziz is on the call. You want to say hi, Abdulaziz?
Hi, everyone. Nice meeting you. My name is Abdulaziz, and I was a undergraduate and a master's student, a graduate student at Berkeley. So I did my bachelor and my master there. Yeah, and I was part of the civil and environmental engineering and data science like program, how to like use data science at Data 100, basically the whole module program, and like how to apply that to some of the work that we did in civil and environmental engineering. So I mostly work with Dr. Matthew DeYoung, and we work on a project related to sensing using accelerometers data that we gathered from the Sather gate and use like some of the teachings from the data module curriculum basically to help like process the data and like gain conclusion, yeah, from it.
Great, thank you. Awesome. Any questions? Dr. Variano, we're coming for you. We know you're almost ready.
Indeed. If a student makes a coding error that makes the code go in an infinite loop, will it use up everyone's flops?
No, that student has 1 gig memory and it will just blow up their little instance and it will just like stop working, and their own little kernel will get frustrated and they will go and restart their kernel and then try again until they debug that error.
Clever.
Yeah, I mean, there's a lot of really cool engineering behind the scenes on how you can do this like in a cost efficient way that like 10,000 people or whatever, or like thousands of people in a day, it'll get scaled up in elastic way and then it will scale down in elastic way, and that these people are really tuned in to like what the possibilities of being efficient on a cloud are, right?
Nice. And so that also means then that students don't have to set their alarm for 3 a.m. to press go on their code.
Right.
Nice.
Absolutely. Yeah, that's an interesting one for like research compute and research IT, right? Like the people that run Savio, that's a little bit more that mentality of like, I will have access at this certain time to run my jobs. And, this like Kubernetes cloud bursting stuff, like you could still schedule things, but you could just let the, computer itself dictate when it has the headspace to take on the next job and stuff.
I have a question.
Sunny.
Yeah, I just heard you say Savio. So I requested an instructional allocation. I know this is out of scope, but do you have any best practices for new people trying to navigate that?
Yeah, I don't know about that very much. I know, I have colleagues or like the Bology for Savio. I used to know a bunch of those folks and they would, hang out in AIS and have drop-in hours. So like hanging out with me in Bology, like find the people and go over and hang out with them and get them, I know that they're there to meet with you and hang out with you and figure out use cases. Just like Jupyter, what's another person with a similar class? Oh, how did they use it? Like that's going to be a great on-ramp for you. And then, of course, with the Jupyter hat on, we hope that over time, there will be more Jupyter access to Savio that just allows people to sort of go on in a flexible way as well, right? So to everybody on the call, there's this idea of like, what Bology and I are bringing to the table is 1 gig per user, right? Which for instruction is great, and make sure that when you're making your teaching materials, you scale it down so that, you fit onto that 1 gig per user. If you need more RAM, we can talk about it. We could potentially scale up your class. If you wanted students to do something really complicated and complex, where do you go? And so could there be this way in Savio where you're like, oh, I want to go, have my students throw something onto the supercomputer for 20 minutes and see if that solves, and how do I do that? as I said, the Savio supercomputer people are slightly, I don't want to be like, this ability to be like really flexible with how the compute works is like a newer set of tools. But there will be Jupyter over time access to Savio where, your students are just like accessing it that way, and commands are executing on the big, yeah, Amy Neeser is great. Definitely worth connecting with her. Balaji just threw her name in the chat. All right, I think that's it for us. Who else is new on here that I don't know? I don't know Maria Laura. I think I ran into you once, but I didn't say hi. But would love to chat with you about your class.
Yes. Do you work on mainly with the undergraduate classes?
Mainly with undergrad class, but if you tell us about what you want to do, we'll definitely talk to you about it.
Oh, great. Okay.
Which class are you teaching?
I'm teaching a data-driven methods for control in civil systems. But it's
Cool.
graduate class at the moment.
Does it use Python?
This year. It uses Python, yes.
What packages do you use?
It uses mostly PyTorch and the classical TensorFlow, the classical control and packages, yes.
Cool. All right, well, let's chat sometime.
Yes, definitely.
Nicholas.
Eric, nice to meet you. First of all, thank you very much for what you are doing, because I've been frustrated over the years with our students not being sufficiently aware of how to compute anything. And all of a sudden I can give them assignments. I will reach out to you later because I've been using Python and open source software package for GIS.
Okay.
And I realized that because the students were using the hub, they didn't have the full Python installation on their computers, which created some interesting problems. So I'll reach out. I'm not teaching until next fall. I'll reach out to you sometime in the summer about how to install this on the hub so that the students have equal access. But most of all, just thank you for what you're doing. That's a really impressive operation that I looked at your website and what you're doing. It's amazing. So thank you. And thanks for this session.
Great. Look forward to talking with you. Anybody else that I don't know on here? Robert, I don't know you.
Hi, I'm actually I'm actually a Berkeley alumni. I follow the RTL website and all the education activities at Berkeley because I teach now in Delft in the Netherlands. So it's a bit late for me here, but I just also can echo Nick's comments as well, because I'm really impressed and excited about all the cool data science related things that are happening at the university, especially since I left a few years ago. And a lot of the things that you guys are doing in education there, we're trying to also do in our master's program and bachelor program at Delft as well. It's interesting kind of to see the differences or whatnot, but also what I'm really jealous of is the support that you guys provide to the civil engineering department, because we don't have that at Delft, and I would really love to be able to have the same thing there. You know, right now, like we're dealing with just trying to convince the university management to set up a Jupyter hub, which is really difficult, but as you can see in the presentation you gave, it's super necessary to be able to deliver all of these useful tools to the students easily so they don't deal with coding issues. So thank you for letting me observe.
Yeah, if you want, we have these amazing colleagues at 2i2c.org. If your IT provides intransigent, you could potentially get like basically a UC Berkeley Jupyter hub for anyone through that nonprofit.
All right, cool. I will look into that. I remember seeing that on the slide. Thank you very much.
Okay, bye. Who else do I not know? Vicente.
Hi, Eric. Well, hi, everyone. Thanks for the presentation and examples. I actually not teaching. I am a PhD student in the Department of Landscape Architecture and Environmental Planning, trying to finish my dissertation this year. And yeah, I joined the meeting to get some exposure to these tools. So thanks. This is
Cool.
This is
Welcome.
part of just setting my goals for teaching tools for some foreseen future.
Excellent. All right. Well, thanks everybody. Thanks everyone for coming. Thanks for joining in.